Before we actually build the logistic regression model, it's a good practice to get an understanding of which all variables are going to be useful in predicting the y variable. The y variable in this case is whether a customer has subscribed to a given banking product or not. Let me start with loading the libraries. I'm using the dplyr, magritar and caret package. Dplyr and magritar are used for data manipulation, whereas caret is a machine learning package we will see later on. Use the bit.ly link here to download the dataset directly into your R console. If this does not work for some reason, use the full link that I have shown here. These are the top 6 rows in the dataset. First, I'm going to print out the number of unique values in each of the columns so that you get a feel of which all variables are categorical and which all are numeric. The variables that have very less number of columns are ideally going to be categorical. In this case, age has 78 unique values, so it's evident that it is a continuous variable. So most variables are categorical except for age, duration, campaign, P days, previous, and there are few other variables that contain less values, but from the description we know that these variables are in fact numeric variables. P days is the number of days before the latest contact, and previous is the number of contacts the customer was made before the current campaign. Let's check the distribution of the y variable. So about 90% of the observations is 0. It's not positive, which means of all the observations in a dataset, 36548 customers did not subscribe to the banking product. Looking at the proportions, about 88.73% are zeros. Similarly, let's look at the distributions of each of the other categorical variables in the dataset. What you need to look for here is there any particular category in any of the variables that is dominating the rest of the categories in that variable? If there is any particular category that is almost filling up the entire variable, the chances of that variable being useful is going to be slim because there is far too less variation in that variable itself. So in this case, most folks are employed as admin, blue collar, and followed by technician. Most of them are married. Likewise, education, whether the credit is default or not, whether the person has a housing loan or not, whether the person has a personal loan or not, contact, month, day of the week, number of previous contacts, the outcome of the previous contacts. All these are shown here. I have written down some of the inferences over here. This exercise is mainly to get a sense of what data you are dealing with overall. The next step, however, is to conduct statistical tests to determine if each of the x variables we have is going to be useful to predict the y. Since y here is a categorical variable with only two classes, for the x variables that are already categorical, we can perform a chi-square test to determine if that particular variable is going to be useful or not. Let me do it for all the variables. Those variables where the p-value comes out to be less than the significance level of 0.05 can be considered as statistically significant and therefore likely to be useful in predicting the y itself. The job seems to be significant, so does marriage, education also, default or not also. Whether the person has a housing loan or not does not seem to be significant. The p-value is quite close to 0.05, however. Personal loan, not so significant. This is probably the only variable that is not significant out of the entire list. Like how you can perform a chi-square test to determine whether a categorical variable is going to be useful, you can perform an ANOVA test to determine if a continuous variable is going to be useful in predicting the y or not. Now, for all the x variables that are continuous, I have written down the code for performing the analysis of variance. You can use the AOV command to perform ANOVA. This output is being passed to the summary function to print out the p-values itself. So the age of the client does have a significant p-value which is far lesser than 0.05, and it has a high F statistic also. To understand the internals of what goes on beneath the ANOVA test, please refer to the ANOVA module. Let's do the same for duration. Yes, significant. P days is also significant. Campaign also is significant. So is previous variable also. What goes on here is ANOVA gives a sense of whether the two different categories of Y have a different mean in the age or not. That's what ANOVA tells. If there is a significantly different mean, then it is going to be statistically significant. Let's visualize this further using a box plot. This is how the age of the clients are distributed for the category where the customer did not subscribe to the banking product and the category where he or she subscribed to the banking product. You can clearly see the no category is falling well within the yes category. There's not much of a significant difference between the positions of the boxes. Let's check for duration. Duration, you can see there is a clear shift between the position of the boxes along the y-axis. So this means that the chances of duration being a more useful predictor than age is going to be slightly higher. Let's check for P days. Not much of info here. Campaign and previous. As a next step, let's fix the classes of each of the columns in the dataset. These are all numeric variables. Although all the numeric variables, I'm going to explicitly convert them to numeric class. The y variable is a factor with no as the first level and yes as the second level. Sometimes no may end up in the second level instead, which is not always desirable. So you can explicitly force no to take the first level by using the relevel function and specify no as the second parameter. Nothing will change in this case, but in case such a maneuver is needed, you can run this relevel and bring no to the first position. Looking at the structure of the dataset, we have all the columns as either numeric or factors, which is highly desirable. We don't have any column as character class as such. Next, create the training and test datasets and write it to disk. Now, with a fair understanding of what variables are useful and their distributions, we are now in a position to start creating the logistic regression model.